We're going to start this morning with density. Density, is a physical property that compares the mass of an object to its volume. Okay? So, if I had a cup here, and I fill this cup with water, let's say, and then I have another cup, and I fill this cup with molasses, and then I put the exact same amount in each cup. Which cup is going to weigh more? You know instinctively that the cup with water, this one has water in it, is going to weigh not just a little bit less, but significantly less than the one with molasses in it. Because molasses is much thicker, much heavier, even though they have the exact same amount of liquid in them. We call that density. We are comparing their volume. Let's say they both have 50 mils in each one. But the water is going to weigh about 50 grams, where the molasses might weigh 62 or 65 grams for the exact same amount of volume. You know people that are like that too, especially some guys that think it's all important to work out, and they might be the exact same size as another guy, but they'll weigh significantly more because they're muscle, and muscle weighs more than fat does. Okay, so let's talk formulas here. The formula for density is mass divided by volume, which should make sense to you since the definition says we're comparing mass and volume. The units, always important, are grams over milliliters for liquids, or if we're talking solids, grams over cubic centimeters, which gives us an important comparison. What about a milliliter and a cubic centimeter? I hope that you can see from this that a milliliter and a cubic centimeter are equal. Okay? As a matter of fact, if you had a syringe, if you've ever seen one, on one side it says milliliters, on the other side it says cc. Those cc's, that cc's stands for cubic centimeters. They are equivalent measures. Alright, so the units for density are cc's. So if I asked you to work some problems, and I'm going to leave you some problems to work, if I asked you to, I say you have this mass of 38.2 grams. That takes up a volume of 40.6 milliliters. What is the density? Then you're going to say 38.2 grams divided by 40.6 milliliters. We can find that density is going to be less than 1. And of course, I don't have a calculator. Let me take my calculator. also going to be able to, if I gave you, say, the density and the volume, could you find the mass? You're going to have to do some calculations like that as well. But for now, 40.6.94 grams per milliliter. So there you go. Okay? This would actually be 0.941. I'm going to correct that because we got to use our sig figs. How many sig figs is in this? 1, 2, 3 sig figs. And our second number, 3 sig figs. I should have rounded my answer to 3 sig figs. So that should have been 0.941 gram per milliliter. All right. A couple more important things you need to know is that the density of water is exactly 1 gram per milliliter. So anything with a density of less than 1 will float in water. Anything with a density of greater than 1 will sink in water. So this one that I found right here, this 0.941, it will float in water. Okay, so that's an important thing to know. That is why oil, and when you have oil spills like they had in the Gulf a few years ago, and just recently as well, that's why it will float to the top of the water. That's an important physical property right there that will help in the cleanup. It's bad enough when oil spill and it's on top. Think of how much worse it would be if it was on the bottom. It would make cleanup so much worse. Another thing that you're going to need to know is what about if I don't just straight up give you the volume? Because this is going to be your first lab. And that is, what if I say that, and I'm about out of time, but what if I say something like that you have this odd-shaped object, like a rock or a pebble, that you can't measure the volume directly, then you're going to use what's called water displacement. Okay, and that is where you would fill up your graduated cylinder to a height, and you would measure the volume. Let's say you pour some water in here, and you measure and record that volume, and then you drop whatever sample in here, okay, and it's going to raise that water level. So now our new water level is maybe to here, okay, because now you have some little pebbles or whatever down in here, okay. Now, what is the volume of our sample? Because this is the new volume. You're going to record these two, and what are you going to do? To get the volume of sample, you're going to subtract these two. Okay? And then you can do your density. Alright. I'm going to leave you some problems. Have a good day.